So this is the 2014 AP Calc free response questions. I've done other ones in separate videos. So this one is just the 1, 3, 4, 5, I think it is. 6 is going to be later. So this one you get to use a calculator, and they put grass clippings in a bin and they decompose. So it's pounds of grass clippings that are decomposing every day. Looks like if we put in 0, we had like 6.687 pounds when you started. This is per day, it drops by 0.931. So it's just constantly dropping. So the first thing they want is the average rate of change. I would write this out if I was doing this problem on the AP test, which is just A of 30 minus A of 0 over 30 minus 0. I would actually take this equation and I'll put it in for Y1 of my calculator. Saved me a significant amount of aggravation as things went along. Blast it out, and I believe you will get that it's dropping negative 0.197 pounds of clippings per day. Part B, find the value of A prime of 15. So again, I would definitely put this into the calculator. And then it's just use your calculator to do the derivative and plug in 15 for the value. I think I can actually show that. I might even have this in my calculator already. There it is. All right, quit. So math, I believe it's 8. And everything's in terms of x, because that's just the way it is. Alpha trace, give me the Y1 equation, and then at 15, get negative 0.164. Pounds. Average rate of change is, yep, pounds of clippings. And again, I would write this out a little more clearly. Per day means at t equals 15 days, we are losing 0.164 pounds. You might want to write 0.164 pounds of grass clippings are decomposing every day. C, find the time for which the amount in the bin is equal to the average amount of grass clippings. Sorry if I lost that. Over the interval. All right, so we want some A of t to equal 1 over 30 minus 0, average from 0 to 30, A of t dt. And I had to think about this one. Do I need derivatives? Do I need this? Find the amount of grass clippings that is equal to the average amount of grass clippings. That's the average amount of grass clippings. Let me do this. So I plugged in y equals, I got this in my calculator. I plugged it in, and then I plugged in y equals that, and I found where the two are equal. So here's 2.752. Let me show you where I got that from. Hope you're able to read the first one. If not, there it is. Math 9, 0, 30. I have to divide this by 30. I'll do that in a minute. Alpha y1 respect to x times, should have done this first, 1 over 30. There's the 2.7526. Plug them both in, graphed them, second calc, intersect, found where they intersected. And gave me 1.415. So after doing all that, T equals 12.415 days, which makes sense if you think about it. Somewhere in the middle of the interval. This one was a little tricky. The hardest part for me is remembering we're starting at day 30 here. So, okay, find L of t. Well, A of 30 in my calculator is 0.7829. And I'm going to go out a bunch of decimal places here. 278694. So there's our point. Our point is 30 comma that. Yes. So a prime of 30, again, just using my calculator, is negative. It's still losing pounds of grass clippings. 0.0559. Sorry for the mess. 762123. Now I'm going to abbreviate these numbers just in terms of simplicity, but when I put this in, I would keep it like that. So L of t minus, 0.783 equals negative 0.056. Oh, I think I just figured out where I made my mistake earlier. T minus 30. So L of t, I guess I have to use this model going forward. Interesting. T minus 30 plus 0.783. So there's my answer. They wanted better model, use L of t to predict time which are observed, show the work that leads to your answer. No, it doesn't say that. I'm going to try and use this, see what I get, because I got a very slightly different answer. So what did they want to know? It would be 0.5. So I put 0.5 in here. I put this equation in. I set them equal. I find where they equal. Or you can just do the math here. (0.5) equals negative 0.056 t minus 30 plus 0.783 minus 0.783. Whatever I get, take that, divide by negative 0.056. And then when I'm done, I add 30. So calculator, 5 minus 0.783, negative 0.283 divided by negative 0.056. And I get 5.05357 equals t minus 30. T equals 35.054 days. Sorry about that. Days. Now, what did they get? Yeah, actually, that's right. That's funny. I think if you kept all your decimals here, you'd have gotten a 2 here. Don't get hung up on that. I'm sure they would allow both those answers because they are not clear about the surrounding. They do not say you have to get this within accurately. So, yeah, I guess that's the key. Whenever you set up an equation, go with 3 decimal places, then go from there. All right, that's number 1. Number 3. I'm doing a lot of these. I am actually going to work up high for part A. No calculator this time. Find G of 3. So they give it to us straight right there. G of 3 equals integral from negative 3 to 3 f of t dt, which if we start here, we just add up these pieces. So it's, I'm going to do this whole triangle here. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1/2 5 times 4 plus, now we got negative. Now we're going to 3, 1, 2, 3, which is a little tricky. It's here at 3, 2. How do I know that? 1, 2, 3, 4, 1, 2. It's down 2 over 1. So here it's down 2 over 1. So that is 1, negative 1, which is 9. So that's A. Couldn't see any of that. My apologies. So yeah, I just blasted all that out. B. At open intervals, graph both increasing and concave down. A graph of G. G is the integral of this. So to find where it's increasing, I take the derivative. Derivative of G of X, G prime of X equals F of X. So I want to know, find where this is increasing, find where this is positive. So that's from increasing from -5 to -3, 5, -3, union -3, 2. G double prime of X equals F prime of X. So concave, increasing concave down when the slope of this line is negative. So -5, -3, 0, comma. Actually, technically already 3. Where are we going to? 4. So increasing and concave down, -5 to -3, and 0 to 2. Yep, that's it. Part C. Function h is defined. Find h prime of 3. H of x equals g of x over 5x. H prime of x equals low, d high minus high, d low over low squared. H prime of 3 equals 5 times 3 times g prime of 3. G prime is just f of 3. Plug in 3, get out -2. Minus g is g of 3. We already did that. That's the first one. 9 times 5 over 25 times 9 equals -30 minus 45. -75 over 25 times 9. By the way, I do this a lot. I don't have a calculator. -1/3. Rather than do the math and undo the math, I just do it once. Yes, I could have multiplied 25 and 9 first, but I think that was easier. Okay. Function P is defined by P of x equals f of x squared minus x. Find the slope of the line tangent of the graph of P at the point where x equals -1. Find the slope of the line tangent to the graph. So I want P of x equals f of x squared minus x. P prime of -1 equals f prime of -1 squared minus -1. I screwed this up earlier, so really recommend doing it this way. 2 times -1, chain rule in this, minus 1. That seemed awfully easy. Yeah, I still messed it up earlier. Equals f prime of 1 plus 1, 2. Let's see. This graph of f prime at 2 is -2. Yeah, -2 times -2 minus 1, -3. 6. Fancy math. 2 down, 2 to go. Running out of colors. I have to do the last one in black. Oof, that'd be horrible. Okay, number 4, train A runs back and forth on the track. Train A's velocity, given differential function, time t is measured in minutes, like values given in the table above. Average acceleration from 2 to 8. So, average acceleration VA of 8 minus VA of 2 over 8 minus 2 equals negative 120 minus 100 over 6, which is negative 220 over 6, which you could leave it like that, although you would have to put the units on, which I'm going to do in a minute. But as a math teacher, I just can't do it. I got to reduce. And that will be meters per minute. Meters per minute squared. B, all right, the data table conclusion. Now I forgot this part earlier. Differentiable function. Since V of A is differentiable, it is continuous. Therefore, by mean value theorem, since VA of 5 is 40 and VA of 8 is negative 120, yeah. Train A's velocity must equal negative 100 for some time between, I'm gonna A, spell that properly, but B, 5 less than T less than 8. Done. What a pain. I'm going to go up top to do part C, just so you can see the data at the same time. C. Time 2, 300 trains moving east. Okay, so I don't know what to call it. I'll call it SA of T, actually of 2. 300 east of Oregon Station equals 300. So to the east, we're going to say it's positive. To the west, we're going to say it's negative. Whatever. Trains moving east, right expression using the position of train A, and we're going to time t equals 12. So we start here, we get to 12. We got to do this whole trapezoid thing. Yeah, sure. So position of train A at t equals 12 is 300 plus 1/2. Now, I always graph this, but I'm not going to today. That's the base, 2 to 5, and these are the heights, 100 and 400. 1/2 times 3, 100 plus 40. Plus 1/2 times 3, 40 plus negative 120 plus 1/2 times 4, negative 120 plus negative 150. How do you want to do that math? It's entirely up to you. If you blast these out, you will see that some are negative, some are positive. You start canceling all over the place. But I am just going to say, hey, I did it. I'm going to get negative 150 meters. So train A is 150 meters west of origin station. Isn't that cute? I love it when math teachers try to be adorable. Fortunately, I don't do that very often. All right. We've talked a lot about how they kind of wedge these questions into 9 points. So now they're like, oh, we're kind of out of what we can ask them. Well, let's make a second train. This one, I need all the space at the bottom, so bear with me. This is hard. Second train travels north from origin. It's funny. Right, so this is train B. Don't care. 400. And we know that according to the second one, and this is a big question, people are like, well, how do I make that assumption? Well, you know what's going on at t equals 2, and they're doing it again. So it's 300 over here. This is your x, this is your y, this is your z, which, by the way, happens to be 500. 300, 400, 500. So x squared plus y squared equals z squared. It's a rate. Yeah, 2. 2x dx dt plus 2y dy dt equals 2z dz dt. Okay, 2 times 300 plus the rate at that time, 100, plus 2 times 400 times the rate at that time. Let's see if I can't figure that out. They said the velocity is this, so I plug in 2. Let's do it here first. 120 plus 25, 145. 4 times 5 is 20, 145 minus 20 is 125. Definitely would do that somewhere else off on the side. 2 times 500 dz dt. Let's see if we can't make this a little bit easier on ourselves. So boatloads of zeros everywhere. By. 600 plus 500 times 2, 1,000, equals 10 dz dt by dz dt equals 160 velocity meters per minute. I won't lie, that's about as hard as it comes, but having seen that, that's part D. Having seen that often enough before, it doesn't freak me out. I'm like, oh yeah, I've messed with this stuff before. First time you see it though, especially if you haven't done that since, I think it was unit 7, might have been 6. It's hard. All right, this one's both very easy and very hard. So, let R be the shaded region, line blah, 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 find the area of R. Ooh, I've used purple, I've used green. My blue pen died, oh no. Let's go with a JB pen here. A. Area of R equals integral 0 to 1 The top one, x e to the x squared minus the bottom one, negative 2x, equals integral 0 to 1, x e to the x squared dx, plus, yeah, I'm going to definitely leave space, 2 integral of x dx 0 to 1. I'm going to box this in a minute. U equals x squared du equals 2x dx, dx equals du over 2x equal, oh, forgot this part, u of 0 equals 0, u of 1 equals 1. See how much sloppier my handwriting is? It's so much better with the other stuff. 0 to 1, dx is du over 2x. I'm going to pull the 1/2 out. X e to the u, du over x. The 2 is right here. Pi. So hard to cross things out. I'm going to try and save some space here. Not in a big way, but equals 1/2 e to the u, 0 to 1, plus x squared over 2, 2's cancel, 0 to 1, equals 1/2 e to the first minus 1, plus 1, equals e to the first over 2, minus 1/2, plus 1. By the way, you can finish right there. Equals 1/2 e minus 1. Negative 1/2 plus 1 is 1/2. Plus 1/2, factor out either 1 plus 1. Yeah, that'll do. Cool. Tricky stuff. Right, do not evaluate an integral expression against the volume of the solid generated. Yeah, this one kicked my butt. I won't lie and say it was easy. I don't think I would ever lie and say something like this was easy. It gives the volume of the solid generated when r is rotated about the horizontal line, y equals -2. So now we're down here. How do I know this is where -2 is? Because that's -2x, plug in 1, I get -2. This point is 1, -2. We're revolving around that. So we're going to do the top part first. No, we're going to do everything. We're going to say the whole shebang. 2 plus this. So volume equals integral 0 to 1 to the pi out front. The whole thing. 2 plus x e to the x squared pi r, radius is 2 plus 2 plus 2. Yeah, okay, that works. Subtract off this region. Pi's out front. Now we got some, oops, sorry about that. Now we got some work to do. I got this wrong earlier. I could just look at the answer, but I want to try and figure out what I did wrong. This distance is 2. This distance is the y value. I want to subtract off 2 minus y. This is not what they do. I know this, and it bothers me. I got to think for a minute. I know I'm confused. I can't figure out how I would just do this area here. The radius out would be, oh, I'd have to subtract off -2 squared since I didn't. Okay. I'm cool with that. All right, so this is not what they do. I know it's not what they do. No, it is. All right, I guess I'm not insane. That was insane. So I want the y, pardon me, I want this area here, which is 2 minus, there it is, because it should be -2x. I gotta think about this one. Take this off. just a cone. It would be like if I was above the line and I was just rotating it about that, I would just say negative 2x plus 2. Yep, I don't have a good answer for that one. I do apologize. But that's it. It's 2 minus 2x. It's like resetting the x-axis to here and then going from there. Yeah, I really struggle with that one. Hopefully it makes more sense to you. Don't forget, every now and then on this test, we just take it. Just deal with it. Right, do not evaluate use the perimeter of our perimeter. Let's do the triangle. 1, 2, don't care that it's negative. Square root of 5. Don't need it because it matches up to the other side. Okay, so perimeter. Let's do this piece. Don't care, but this I need. Plug in 1, I get e to the 1. So this is e long. All right, so perimeter is root 5 plus 2 plus e plus, right, but don't evaluate, integral from 0 to 1. Fully, I got to go over here and do some work. I need y equals x e to the x squared. I believe I'm looking for square root of 1 plus that thing squared. dy dx equals, leave it, times e to the x squared times 2x plus derivative 1 e to the x squared, which is 2x squared times e to the x squared plus e to the x squared. Well, I hope that's right. I'll write it easier. E to the x squared, 2x squared plus 1. I think that's easier to write. Hey, look at that. I got it right. Very cool. So we add up those pieces, and then we get this e to the x squared, 2x squared plus 1 squared dx. Right, but do not solve. Wow. Well, that's the reason we're practicing in February for this fun stuff. That will have to do for now. Good luck.